which connects to a database.
That
Which
is
connects to
not,
the application. Should we
that's not
use
necessary.
that database?
I can show you anyway, but that is not necessary. You know, of course, you create the login. For that login, you now grant him create database. There's a role. There's an existing role as DB creator, right? So the simple way is to use this role. But for what they are talking about, you can easily create the database and then you change the ownership of the database to that guy. You know that already, right? So you just change the permissions, the security permissions, and then sorry, you can do that from here. Assuming I wanted to user mapping, yeah. So I want this guy to be DB owner. I can do that. I don't need. He doesn't need to be the one. What's this? Something's wrong here. To create. But if you want to avoid the political aspect of the technical work, you can use the person DB creator. But you know that means he can create a database at any time he wants. And when you have auditing, the auditors will point it out. Guaranteed. Guaranteed. The auditors will point out users that have excessive privileges. And you have to justify it.
Okay.
So if it has to happen, they have to specifically request it, and then the internal control guys have to approve.
Okay.
Okay, so let's see this simple database creation. Now, this statement creates a database with multiple file groups. Remember, we've all been creating our databases with 2 words, right? Create database, then put the database name. This time we're going to specify the different files, specify the physical file names, the sizes, file growth settings. Typically, I don't allow my file growth to be more than 1 gig. And typically, I don't even want the file growth to be too small. Why? Because I don't want the growth to be happening too often, because it can have a performance impact. So, and then I add another file group to this database, and a different set of files. This is a good way to create a large database with many files on it. And then I define where I want my log files to be. So this was done for a different environment. So I'm just going to I'm going to get my, first of all, before doing this, I need to be sure that I have enough space for all this English I'm typing. So my size is, this is 1 gig, this is 2 gigs. So I have more than enough, right? I have more than enough. But let me get the correct path. So I want my data files here. So let me do the trick, the SQL Server trick. Okay. You see MS SQL data, right? Then I want my others guys here. Okay. And then this guy will be at the log. Containment, none. So this is another topic in containment. You can, from SQL Server 2012, you had what we call contained databases, where everything that the database needs in terms of, particularly in terms of users or principals, is stored within the database itself. So if you plug the database, it's just like pluggable databases in Oracle, which came later. If you shift the database, plug it from one instance to another, it will already have its own credentials along with it. So that's for contained database. That's another topic. So let's do this. So let's see what happens. So in my data files, SQL will start creating all the data files one by one, right? What is this? Okay, 4. Okay, when it starts doing that, it goes to drive E and starts creating 5, 6, 7, 8, right? And that does the creation also. Okay. All right, good. Done. So we now have our DB2, DB2, right? Yeah, DB2. If I go look at the properties, I'll see that file groups, it has 2 file groups based on what I specified, right? Each of the file groups has 4 files, and these are the files, rows data, and yep, all the sizes I specified are there. The auto growth settings are also there. Okay. Okay, so basically that is what has happened. The locations of the paths are there, and so on and so forth. All right, I can decide I want to add a data file db06 to file group 1. There's a statement to do that. Invalid file group. What's the name of the file group again? It's FG01. I'm sorry. Yes, DB2. Oh, sorry. I've used this name before, right? No, I've not. So let's call this 9. DB2. I'll group this. Size is KB. This is 262 MB. So let's go. Alter database, add file. The name of the file is the logical file name. The file name is the physical file name with the full path. I specify the size, the group, auto group settings, and I specify the file group. If I don't specify the file group, it goes to primary. All right? So again, if you look at the properties of the database, we see that we've added another file called the file 9. We should have 9 somewhere there. What did we call it? We called it, we still called it 6. Okay, sorry, but the physical file name, we called it 9. 9. So the physical file, we called it 9.
The second one.
Yes. Okay, that's fine. Okay. So that's for that, and we can also resize databases by saying alter database db2, modify file. Let's say this 9 file. Remember here, what you're specifying is the logical name, right? And if we're specifying the logical name, in fact, let me use this to show you something. Then we're resizing it to what? We're resizing it to, let's resize it to 1 MB. If I try to do this, there's no file called db-file9 because what you're supposed to specify here is the logical name, not the physical name. Okay? Equal, okay, 2 MB. Our modify file specify size is less than or equal to, 5 gig. Oh, that's too much. Is it too much? This is KB, this is MB, 262 MB, okay, 1 GB. So let's just do 1 GB. So you cannot use modify file to reduce the size, you use it to increase the size of the file. Okay. As you can see, the jump is high, so it needs to take a little time to do that increment. So those are basic things. Now the shrinking of the file. Let's say I wanted to remove db file 6. I can, to use the empty file option. This shrink file, this is the same shrink file you can use to reduce the size of the file. But when you use the empty file option in this command, you basically prepare it for removal. When you use empty file, what you're actually doing is all the objects that are sitting in that data file, they will move to other data files in the same file group. So it will now allow you to be able to, because you cannot remove a file group if you have objects sitting there. So for you to remove a file, you cannot remove a file if you have objects sitting there. So for you to remove a file, you need to empty it first. So you basically would, empty it first and then remove it from the system. That way you go back to your 4 right? 4 files in each file group. Remember that we had 5 before. So our db6, db file 6.
Hello.
Yes.
So please, with the emptying of the data in the files, where does it go to sit?
Yes, I said it will go to other files in the same file group. In production, that operation you just saw now can take a very long time depending on the size of the data file. So don't be deceived. So basically what it will do, and typically if you want to do that kind of thing, it is best to create another data file somewhere. Let's say you just want to relocate. It's like when you do your rebuild of your clustered indexes. You know what is, if you do a rebuild of your clustered indexes and you specify another file group, your table is basically moving to a new file group, right? In the case of empty file, you're going to be rearranging your table and putting the pages of that table on different files within the same file group. So it can take quite a while,
Okay.
So basically when you say shrink file, empty file, all the tables, indexes, and other objects on that file will move to other files in the same file group. So you can now remove the file. It's another good way of defragmenting your tables already. So you must make sure you have enough space in those other files to take it. Otherwise it will run for a while, then break, and then you have to start again. All right, let's do one more thing before we go. Let me see. This is another additional investigate allocation units. Remember, okay, so let's reconnect. All right, you know why that happened, right? Because we had restarted the instance. Okay. Okay, typically you will encounter also in tables in cases where you have something called allocation unit types for user data, right? Now, in-row data is basically saying, oh, these are normal data that I have written to my pages, the pages of my data files, right? Now this is too much information. Let's do a simple one. I have AU. I have already created this, so I'm not going to do it again. I have two tables in AU, which I've called one of them standard and one of them overflow. I want to use this script to extract information about the way that these tables are structured, right? Now, when I created these tables, right, I created the standard one, right? I created it with a column. One of the columns is a varchar 8000. 8000 is the limit in terms of the size of a varchar of the varchar data type. Now that means basically I'm at the edge of one page. So this table is guaranteed, well, not guaranteed, but I mean it's likely to be sitting on one page. Okay. Now I create the overflow table and I add two columns. One of each of them is 8,000 characters in length, or 8,000 bytes in length. And what happens is that this table will now, it cannot sit in one page, because remember the size of a page in SQL Server is 8 KB. So this guy is likely to go beyond 8 KB. So when you look at the details of these tables in, as you query them with these when you query these system objects, these catalog views, system internals, allocation units, and partitions, you're going to see that my overflow table has two types of allocation units: in-row data and row overflow data. My in-row data is sitting within a page, but my row overflow is telling me that this table is sitting across two pages, or more than one page. Let's put it that way. My standard table, it's limited to one page because I only had one column there. So the more columns that you have, the more the wider your row, the more pages your table will span across. So you see that in production, most of the time in production, your rows probably span across more than one. But that's one reason why, if you don't need a VARCHAR of 8,000, don't create it. It's better for your, to avoid things like row chaining, it's better for your table to sit in a limited set of rows, so that when the data retrieval is happening, in most cases, it will require fewer number of reads. So let's look at something. Let's even try to simulate whether maybe we can simulate it. Use AU. I've not put any data in my distance, so I don't know whether this will standard. I don't know whether this will. Okay, I think we have to populate the data first. Let's see. Let's populate some data. Where are you? I think we don't need this anymore, right? Okay. Well, let's experiment it first. Manipulate. All right, so let's populate some data in the row overflow. Before we do that, we'll do the experiment and select from it first. DBO. Standard. Okay. It's called standard, right? Yeah, standard and then overflow. Okay. So before we do that, let's set statistics. IO on. Okay. Set statistics time on. Okay. Statistics. Okay. So let's see what happens here. Okay, now we're not going to get much count. Scan count 1, logical reads 0, logical reads 0, because the tables are empty. So we're going to do what? We're going to basically populate the tables. So in the overflow, we insert 2 rows, and then we check it again. Basically, what we have done is we have filled up the entire 8,000 VARCHAR data file, and the entire length of the VARCHAR column. Now, logical reads 4, physical reads 0, So what it says is I need 4 reads to just get this 2 rows, right? 4 reads to get the 2 rows. Let's do that for standard. Standard has only 1 column. Okay. So on okay, this is standard. The same 2 rows, right? So I read 2 rows from here. In the case of table 1, I have 2 rows, but I have 1 column. Table 2, I have 2 rows, but I have 2 columns. Now, how many logical reads is that for me? Now, in the case of table 1, I needed 2 logical reads to fetch the entire data from the table. In the case of table 2, I needed 4 logical reads. This is not because it has 2 rows. This is because of the length of the fact that I needed to basically pick 2 pages. Yeah, I needed to pick more than 2 pages, actually 4 pages in this case, because each of my pages is limited to 8 KB. A single read will pick 8 KB of data. I hope that is a little clear. So if you can keep your tables within your IO performance is improved as you are able to maintain a narrower set of columns. Now, what this implies is that when, for example, you are using the varchar variable, the varchar column data type, you just specify the length that you really need. Of course, you will agree with me that a typical production table cannot have just 3 rows. Well, typical will not have just 3 rows. So even if you have 10 rows, you must organize your database in such a way that you are not occupying too much space at the physical layer. So that is for that. All right. So these are, I don't think we can go further on this in some other ways, but these are some references for further reading. Maybe I'll put all these references in the video, in the video description. So any other questions? Theo has been quiet since.
Apparently, I think he went off.
Oh, okay. That's fine. So any other questions from you? Have you found what you were looking for in that specific case?
Yeah, I've not logged into
Okay.
it again.
So when
So
you find out, we can look at
that one,
that.
do that one later.
Okay.
But I think I'm okay.
So did you get something from this session?
Yeah, especially moving. So
Okay.
the moving of the data files. So that means that anytime we are moving, there would have to be a downtime
Yes.
with some instances.
Yes,
Or
they'll have it during the downtime, but try to limit the downtime to the database. You can take it offline rather than shutting down the instance. But you know that before you take a database offline, if it's a large database, try to disconnect all the users first, or better still, stop the app. That way, because if you try to take it offline while the users are there, it may take a long while to disconnect all the users, or it will even hang, and then you will still have to restart the instance.
okay.
All right, thank you for your audience. So next time we shall go a little deeper. And if you have any specific areas you want us to cover, you can message me, and then we can try to also focus on those areas. One of my plans
All
was
right.
to divert a little bit into the querying aspect the next class, but and I think that may be useful. Then we do that.
Okay.
All
Thank
right.
you.
Thank you so much. Yeah. Later.